Good evening, parents, and welcome to the wonderful world of mathematics. I'm your host, Mrs. P. Same lady you've had all the time. So, anyway, today I want to do a quick video. Quick as in I got to get on a basketball bus to East Buchanan, right, Gower, Missouri, tonight for district basketball for our girls, and then tomorrow night for the boys. So, come root on your Blue Jays. Today, quick video on what we're discussing in class right now. As you're aware by my newsletters, we have started a process in algebra. And the first thing we're going over is expressions. And inside of those expressions, we are including exponents. This is a 5th grade standard that they started last year, but I'm going to show you exactly how they started those and how it's different but the same now in 6th grade. So algebra first, starting off with, I let the students know, is a mathematical process where we're including variables, which are letters, within our expressions. An expression is a math problem that you may or may not have to solve. Once we put an equation to that, which means we're going to have an expression, we put an equal sign, that now turns it into an equation which they have to solve and get the response and solution for. Right now we're working with expressions and we're including those in exponents. And we're going to be working on moving that towards algebra, which means we're going to put letters now in our math work that they have to solve the unknown. So there are 2 types of expressions right now. This is what your students have been used to most of their life. This is 7 plus 3. That's a numerical expression. It means that it only uses numbers. 7 plus 3, and they know it. Once I put this here, they know they need to solve it and say it's 10. Once we start doing this, then they have to start figuring out what that letter is and what it represents numerically. That's now called an algebraic expression, and it's something that we will start working more and more on as we make our way through the month of March. But I've shown this to them, and they totally understand the concept and are excited to get to work on it. For now, we're still using numerical expressions, only we have added exponents in them, and I want them to solve those. So just real quick on our exponents. Your students learned exponents in the 5th grade. They learned exponents like this. This lovely thing has a name. This lovely thing has a name, and there's a certain thing you have to do to it to solve it. The way I teach exponents to students is, this is called a base. Like a military base. What do? They protect, serve, and support you. That's what this number does in this mathematical expression. That is the base, and this lovely thing is known as the exponent. Now, where we come into trouble with this is, students see this and they think, oh, that's 20. 10 times 2, it's 20. That is not what that means. A base number means that that is the base that you're using in your expression. Those are the, for us, add-ins or factors that we're using in the actual expression. The exponent is how many times you're going to take that base. Your kids also will call this a power of. So this is 10 to the power of 2. What that means is then you have to take 10 times 10. Once, twice. Hence that gives you the power of 2, or the exponent of 2. And the real answer, solution to that problem then, is 100. Now they learned this last year, but they only learned it for a base 10. Same but different with Mrs. P, and that's why sometimes we get in a little trouble. Because when I first put up problems for students in class, example, 7 squared. Your students do one of 2 things to me. And neither one of those are correct. It is not 14, and it is not 700. And why they have run into this problem is they look at this and think it is a multiplication problem. And I tell the kids, I wouldn't be that tough on you. Hopefully you don't think I would trick you that bad. If this is a multiplication problem, I would write out 7 times 2. But that's not what I wrote. I told them, I don't have that much power. Do you think you get to 6th grade, and instead of writing 7 times 2, I say, oh, get rid of the multiplication sign, and I'm going to put that 2 up there in the right-hand corner, make it itty-bitty, because Mrs. P is so powerful, the wonderful power of Oz. No, I can't do that. This is what is known as a base and an exponent. And so it is not a multiplication problem in the sense of take that times that factor times that factor. It's a multiplication problem in the sense that I have a base and I want to multiply it by itself 2 times. Once, twice, 2 times, which actually makes it the answer of 49. So there's the first problem they run into. They need to know it's not a multiplication problem in the sense of the standard writing of multiplication. If it was, I would just do that. The other thing they need to remember is they don't want to get it confused with what they learned last year in 5th grade. This is for scientific notation. Why? Because if Mars is 10 billion light years away, how many of you want to write out the name 10 billion or the number 10 billion? You don't. Instead, you want to write it as a power to, 8 maybe, 9, I can't think of right off the top of my head. You don't want to write out 10 billion. You want to write it as a power of. So when they come to Mrs. P, the problem they have is they've learned it this way, and that's all they think about as a base and an exponent. So hopefully now I've explained it really well to them, and they'll realize, oh no, this isn't a base 10 number. It doesn't look like 10, 100, or 1,000. It's 7. So what does that mean? I take the base 2 times 7 times 7. It doesn't mean take 7 and add 2 zeros. Because even 7 times 2, as they said, is 14. And 7 times 7 wouldn't get them 700. So I don't want them thinking about really base 10 numbers if we can avoid that. I just want them thinking about what does it mean when you have an exponent. And no matter what you have, 1 to the power of 5, 6 to the power of 2, 4 to the power of 5. What an exponent means is you take that base number, you take that base number 5 times and you solve it. So 1 times 1 times 1 times 1 times 1 is 1. 6 times 6 is 36. 4, 5 times, I start having them just multiply it out. 4 times 4 is 16. I have them draw a line to say times 4. They're going to get 64. Draw another line out. They're going to get 256. Draw another line out, and they're going to get, as I do this in my head, 1,024. That's what powers and exponents mean, or base numbers and with exponents. This is your base. That's your exponent. That's what we're working on right now in class. We're eventually going to switch it to this with exponents as we move forward. If you have any questions, thoughts, feelings, or concerns, just let me know. I hope you have a great evening, and I'm still, once again, having a great time with your students, hopefully engaging them and intriguing them to really try to solve math, and then that's what makes it fun. So hopefully they're having a good time. Until next time, have a great night. I'll see you later.